Welcome back. Let's just hope this is the lucky number 3. So this will be the third time I'm recording this video. Hopefully it does record this time. Okay, so in this video we are continuing with our series on casual game mechanics. Today we're doing swerving mechanics, which is best known as your infinite runners, your lane hoppers, that sort of thing. So let's go ahead and get that working. What we need to do, if you look at my awesome little scene here, I've just created a sphere, which is going to be my player, and I've created a stand-in level. So the stand-in level over here is just, I'm going to replace this with a procedurally generated level at a later stage. So this is just for play testing. So I'm not too bothered with the way it looks. So my little player is a sphere here, and I've just got these obstacles just for testing. So we're going to be doing this one in bulk, so let's jump right in. If you look at the character, we got a sphere glider and we got a rigid body, because I'm going to be using physics to move this character around. I've enabled gravity so that if I want to do a jumping mechanic like they have in Subway Surfer, I can go ahead. But I do want to freeze the rotations, just so that I don't, if I replace with a character, the character doesn't run around like an idiot. So let's go and add a flow machine. And in the flow machine, we're just going to create a new script. Clearly, I still have it here, so I'm going to replace my swerving here from our previous video attempt. And here is the graph. Click the Edit Graph button. We're just going to maximize this graph, and we won't need the start, but we will need the update, but it needs to be a fixed update. Again, a reminder, we are using physics, so fixed update is going to give you consistent and reliable results. What are we going to be doing? In the past, I've always used add force or add velocity. So this time I wanted to try something a little different. So I'm going to do rigid body dot move position. And what this does is it physically moves the rigid body. Instead of adding force or velocity, it says, I'm going to pick you up and I'm going to move you over here. But what's nice about this, as opposed to a transform dot position, is it still respects the collision detection, and it will stop the object from moving. So you can try to push it through a wall, but it ain't going to go through that wall. So it'll kind of maybe slide around the wall to get to the target that you're trying to get it to. So that's why I'm using this as opposed to velocity or add force, because I want to control, I don't want any kind of inertia, I don't want any kind of follow through, I don't want any kind of dissipation of velocity over time. So when I release the button, it take a little bit for the character to slow down. I don't want any of that kind of stuff, because this is a mobile game. You don't need any of that kind of stuff. And I don't want to go and keep reminding myself to set the velocity to 0 whenever I want something to stop. Instantaneous. So we're going to split this into our vector 3, x, y, z. And we are, for now, only caring about the z position. So we're going to do that first. And the way we're going to do that is we need a object variable, and we're going to call this forward speed. Why not? And it's going to be a float. And for now, I'm going to set it to 5. We're going to drag this in. We're going to be multiplying this value, and we're going to be adding this value to the current position. So that's how a move position works. First, you need to say, what is the current position of the object? And all I care about in this case is a v3.z, because I only care about the z position. And we say, okay, so what is the current z position? And then we're going to add, and then we're going to plug that into the z. So we're going to add a value to this and then move the object to this new position, new location. So I'm going to use the forward speed, and again, I'm messing around with physics. So I'm going to take this value and I'm going to multiply this value before I use it by time dot fixed delta time. So let's test this out. So now this should allow the object to move forward. We're going to test it to see if it works. There we go. He's moving. So I can move it back, and it'll keep trying to go forward. I can't currently move it side to side because remember our rigid body dot move position is set to 0 both in the y and the z. So it's going to struggle to meet that position that it's trying to get to. but it's working. It's moving forward. So let's complete this character move section. So that is done for the Z. So I'm just going to add a group just to kind of see what each section does. This one is going to be the forward movement. So epic. And so I'm going to change the color of the group to be blue, because that is the color of the Z axis. And now we're going to do the, I still want to add gravity because I do want to do jumping, just kind of like Subway Surfer, that sort of thing. So I do still want to be able to make the character jump. So I'm going to just do a rigid body dot velocity. And in this case, I only care about the Y. So I'm going to go v3.y. I'm going to plug that directly into the Y position. Sorry about that. And this one's going to be simply called gravity. I'm going to make this group a green, the color of the y-axis. And then all that's left to do is to kind of update the X position. Where are we when we press the buttons to move the character from one lane to the other? So I don't want it to be kind of choppy. I want it to kind of be a little bit smoother. So I want to put in a lerp. So that's what we're going to do. I'm going to drag off here and type in lerp. Should be able to do that. There we go. We're going to interpolate a value from the, again, we're going to have to get the current position. So we're going to go transform.position. Let's try that again with the correct spelling. Oh my gosh. And all I care about in this case is the v3.x position. And we're going to put that as the starting position. So where are we currently? So I'm getting the current position of where we are at the moment, and where we're going to be going, and then how long it's going to take us to get there, how at the speed with which we're going to travel to that location. So let's start by creating a graph variable here, and we're going to call this new player X position. It's going to be a float because I only need one value, and we're going to drag that in, and we're going to plug that directly into B. That is the new player X position. Notice how I don't put any values in there because I'm going to be updating that value when I press the keyboard or the gamepad or whatever it is. Now we need another variable in the object section, and that is going to be simply put, it's going to be our time, our lerp speed. So a lerp speed, it's going to be a float again, and for testing, I'm going to make this about 5, just so that you can see that it's working. And once again, because I'm crazy that way, I'm going to multiply this by fixed delta time. So again, in the past, I've had some weird results without using this whenever I'm dealing with any physics related stuff. So I'm just going to be using my lerp speed multiplied by my fixed delta time. And I'm going to be using that as my movement, side to side movement. So let's just move, give it some space so I can reorganize my awesome neatish graph. So we're going to call this one side movement. I'm going to make that red because that is the color of X. Nice. You are not even in there. So when I grab this, you should all go. There we go. And we're just going to pop this down here, and we're just going to move this and neaten this up a little bit. So let's just, and then what I'm going to do is just add a group around all of this, just so we know that this is my, let's call it player movement. Okay, so now that's going to be my player movement. That's going to be exactly what I need to do to get the character to move. So the next point is, how am I going to receive input so I can get the character to lane hop? So let's do that next. So I'm going to do an on button input. Again, you'll very seldomly see me do a get key down. I don't like that. I don't like hard coding keys. I want to be able to just go into here and go to project settings and go to my input manager and either create a new action or multiple actions, so that whenever I'm referring to that name, I'm referring to multiple keys, as opposed to saying W, A, and all that kind of stuff. And then I have to go back into my code and change that when later on, if I change my mind or if playtesting comes back as those were a very poor choice in keys. So for this case, I'm going to be using horizontal, and only when the button is down. So when I click the when I click the A key, the D key, or the side arrow keys down, I want to do something. What is that I want to do? I want to go to the graph, hold down Alt, and drag in my new position, and we're going to update this new position. Sorry about that. To clear my throat a little. Been doing this video 3 times in a row, so I'm a little bit done. Okay, so what are we doing here? We're doing the exact same thing we did before. So we're going to go transform.position. I cannot for the life of me spell transform in the last 5 minutes. And all I care about in this case is the v3.x. And we are going to be adding a value to this position. And then after we're done with that, we are just going to simply plug that in to update the x position. What is the value we're adding? We haven't actually created a variable for that. So let's create a variable. Let's call this x input value. X input value, it's going to be a float, and in my level it is 2. You can change this value. That's why I'm making an object variable, so it's easily to access in the editor. So if it doesn't feel right, you can just change that value. I'm going to drag the x input value here. And before I do anything else, remember this is only a positive value. What happens when I hit the key to the left or the right? Again, I don't like doing that whole, if it's A, then make it a -2. If it's D, make it a +2. So I prefer to go along the lines of saying input dot get access raw. The reason I'm doing an input dot get access raw is so I can get a pure integer value out of this. So it's either going to be -1, 0, or 2, 1, and we're going to take that and we're going to multiply that normalized value by whatever it is that we're trying to move it by. So if I press the A key, I'm going to get a -2, and if I press the D key, I'm going to get a +2. That is it. So let's try this one more time and see if this works. You'll see, and then it's kind of broken a little bit, going to be a little bit janky, so I'm able to keep moving. So if we rotate around here, notice how I can keep moving. So I want to kind of limit my player movement within the confines of my track. So if I look at my character, it's currently 0 in the X, but if I move it to the extent, that is 2, and that is -2. So I'm going to limit the amount of movement that my character can do. So before I even tell this movement what to become, this value, I'm going to first clamp that value. Sorry about that again. And I'm going to create a variable. Again, I always code around artist-friendly stuff, so I need a value here that we can change in the editor. So I'm going to create a clamp values. Let's make it plural. It's going to be a vector 2 because x is going to be my minimum value and y is going to be my maximum value. So I know my minimum is -2, my maximum is 2. So I'm going to drag that out, and I need to split this into its x and its y. So I'm going to go v2 this time dot x. That is going to be my minimum value, and let's go v2 dot y. That is going to be my maximum value. And that's it. We have now clamped. Now be aware this is clamping it directly from 0. So if your character is somewhere else in the scene, you're probably going to want to grab the current player X position, add this clamp value, and then add it to the clamp value, then add it to your minimum and your maximum. That way it is exactly the way it's supposed to be. So let's just actually do that. So I'm going to grab this, duplicate that, so that we can move the character anywhere, and we're going to go and say add this, and that is going to be my sorry, wrong way. Let's add this value. So add, and we're going to make that our minimum value, and we're just going to duplicate it, and we're going to do the same thing. We're going to grab this, add that, and plug that into my maximum value. So all we're doing here, if you're wondering, is we're getting the current X position, and when I'm adding, I'm either adding a negative number or a positive number, and then that's going to be my clamp value. That's going to be where my character can, the extent at which it can move, the distance it can move. So let's just put a comment group around this. This should work. Again, I just did that on the fly. That should work. So let's say player side input. And change this color because again it's making me a little bit depressed. And let's see if it works. Oh, hold on. Panicky, panicky, freaky, freaky. Oh, notice what I've done wrong. I'm actually this position is always updating, so the clamp value is always updating. So we would need to get not the current position, but we would have to get the position at the start of the game. So let's do that, might as well. So let's call this start X position. I'm going to put that in the graph. It's going to be a float. We're just going to use this as the value to which to work to. So at the start of the game, so I'm just going to do it down here because I'm right here. So I'm going to type in start. When the start of the game happens, we're going to drag out the start and we're going to say, what is the current